Hi and welcome. In this tutorial, I'm going to discuss how to access the ports of 8051 for digital input and output purpose. So first of all, I have to create a new project in MikroC compiler. For this, go to Project, New Project. Next, give a name to this project. Select the folder location, select the device and set the clock frequency. Click on Next, Next, Next and click on Include None and Next. Now finish. Now we will get this empty void main function to write our instructions. First I will place a model for simulation in Proteus ISIS. So select this second component mode tool, click on P and search for AT89S52. Double click on the microcontroller. Actually S52 microcontroller is not available in Proteus ISIS, so I am selecting this C52. Double click on it. Now search for network and select this network resistance. Double click on it. Now click on OK. Place the microcontroller on the screen. Double click on it. Change the clock frequency and click on OK. So when we are going to simulate the 8051 microcontroller in Proteus, there is no need to connect the crystal on XTAL1 and XTAL2 pin, and there is no need to connect RST pin or EA pin. Now select the resistance network and place it near the port 0. You can see this is a 10 kilo ohm resistance network. So connect port 0 to this resistance network because the port 0 cannot be used for digital input and output purpose without having this pull-up resistance network. So on this pin number 1 we need to connect a DC source of 5 volt. So select it from generator mode, click DC, place the source here and connect the source. Now double click on this source and mention the voltage 5 volt and enter. Now we can use this port 0 for digital input and output purpose. Now we will write a simple program for all the ports of 8051 and we will try to change the status of every port. So first of all, we know that all the ports of 8051 are also known as special function registers. So when we are dealing with the special function registers, they must be used with capital letters. So if I want to put any value to port 0, then I will use capital P. Port 0 is equal to 0x0f. This is the hex value. Port 1 is equal to 0x0f. Port 2 is equal to 0x0f. Port 3 is equal to 0x0f, and the semicolon is important at the ending of every statement. You can also write a comment with the help of these two forward slashes, and the comment can be any statement which can clear the idea what you are going to do with the given statements. Now after writing these statements, I have to go to build and click on build or press Ctrl F9 to compile the program. Now in the simulation side, I have to assign the hex file to this microcontroller model. So when we double click on the microcontroller, we will get this program file. Click on this icon to browse the hex file 01.hex. So I will select this and open it. Click on OK and you can run the simulation from this play button. Click on it and you can see now all the ports have same status. So all the ports first 4 pins are high and other 4 pins are low because we write the instructions to put the value 0f. Stop the simulation. If you want to make any changes, then go to the compiler and make the changes. Now I have port 0 is equal to 0 and port 2 is equal to 0. Compile the program, build it, and again go to simulation, and there is no need to assign the hex file again. Just click on the play button and now we have port 0, all the pins 0, port 2, all the pins 0, and we have the same status as last status on port 1 and port 3. The other way to write the data on any port is using the binary format. So to use the binary format you have to use 0B then 8 bits of data. Suppose I want to use 1111 then 0000, and this value is in hex F0. So now port 2 will be 11110000. Compile it and run the simulation. Now we can see a change in port 2 status, where all the higher 4 pins are 1 and lower 4 pins are 0. We can also use the decimal format to write the data to any port of 8051. For this we have to just write the decimal value. If I write 255, this value will be FF in hexadecimal, and it will set all the pins of port 3. So click on build and compile it, run the simulation. Now we have port 3 all pins set to high. So this red color is high, blue color means low. So we can access any port of 8051 except that you have connected a pull-up resistance on port 0. You can write the data in hex format, in binary format and decimal format. So in next tutorial we will discuss how to interface an LED with 8051. So thanks for watching and subscribe the channel.